Hi, this is Huili Wang. Welcome to Cloud Access Security Broker CASB Fundamentals. In this video, we're going to continue to part 2 of threat protection. In the last video, we covered identity and access management. In this video, we're going to talk about security posture management, SPM, and the threat detection and mitigation technologies. Another important area of CASB control is security posture management, or there's a term CSPM, Cloud Security Posture Management, that covers basically on the configuration if all your assets, your resources and applications are configured properly. And for example, if multi-factor authentication are activated and data encryption is enabled, and the storage access if it is open to public internet. So in earlier video when we talked about the 2 breach cases of cloud security in 2019, both cases had the fundamental cause, the root cause is security posture management. That was not properly done. In one case, the encryption was turned off was because the IT team was doing some upgrade and they switched it off. And after the upgrade, they simply forgot to turn it back on again. So using automatic CSPM will detect such kind of vulnerability and fix them. This feature, this function sometimes is offered by cloud security provider and integrated into their offerings. The traditional way for anti-malware is by maintaining a comprehensive signature base of the existing malware. But for unknown malware, a good technology in use is Sandbox. Sandbox is simulating the real environment and let the suspicious executable run in the simulated environment and observe its behavior to decide if it is a malware. There's a competition here. From the hacker's perspective, the hacker would like to have the malware deceive or beat the sandbox environment, trying to fool the sandbox, believing that it is a good malware, while on the sandbox, on the protection side, it would like to simulate the environment to let the malware believe that it is running in the real environment. So there's a competition in here. A good example of anti-sandbox or anti-analysis techniques use case is the Wannacry Ransomware. The attack took place in 2017. It spread across the world, and especially health centers in Europe took a big hit. A ransomware is a malware that, once infected, would encrypt the hard drive and then prompt to the users in the message box like this, asking users to pay a certain amount of ransom. In the Wannacry case, it asked users to pay the ransom in Bitcoin to get the files decrypted, and that's why it's called ransomware. When the attack took place, a number of security experts were trying to stop the spread, and they tried to reverse engineer the malware, and they found that inside the malware, a very random domain name is used. The malware was trying to connect to this domain as a kill switch. If it's after the attempt to connect to the domain was successful, that means it's in a simulated environment, not in the real environment, because such domain is rarely used. And then knowing that it's in a simulated sandbox, it would stop the execution to escape the detection. But if by connecting to this domain, it got a failure response, and that's expected, and that means the malware would know that it's in the real world, so it went ahead with the encryption of the hard drive. And the security expert registered this domain. After registration, the domain became a valid active domain. So each malware trying to connect to the domain would get a successful response, and it took it that it's in the sandbox and stopped the execution of the malicious code. And that's how the Wannacry ransomware spread was stopped. So such kill switch is a typical example, and there could be other techniques to escape sandboxing, or called anti-analysis. For example, the delayed execution of the malicious code until the monitoring cycle ended, and that's the way to escape sandboxing. Or the malware would scan the hard drive or memory and even measure the CPU temperature to ensure that it's in a real machine. And there could be other methods like following or tracking the mouse move to make sure that it's interacting with a real user, not a simulated environment. One important part in the threat landscape is insider threat. It could be disgruntled employee or insiders with malicious intent. And that's one of the hardest part to detect. It would be requiring a lot of intelligence and to set up a normal pattern for users and to detect the abnormal or off pattern behavior. For example, an employee typically gets offline during weekend and all of a sudden was detected online and downloaded tons of critical business data, and that would require some intelligence in place to report that this is abnormal behavior. And another example could be a login attempt made from the IP address in California, and 5 minutes later, the same account submitting a request from the IP address in New York, and maybe to a different application, but as long as from the same account, then it's quite suspicious because it's highly unlikely the same user would travel from California to New York within 5 minutes. So this is definitely a red flag. Okay, we talked a lot of technologies. Let's have a quiz to reflect what we have learned. Here's the question: which of the technologies does not directly enforce control? Pause the video and give it a thought. Yes, the answer is data classification, because when you classify the data, that is, you link the category to the data, it didn't trigger any action of the control enforcement, while email encryption that changed your email content from plain text to crypto text, and user behavior anomaly alert, well, there's alert raised, and so there will be follow-up actions, or at least an event it is noted. And access authentication, there will be access passed or not passed, so definitely there will be control there. In this video, we discussed the critical functions in CASB control part. And moving on, starting the next video, we'll begin to talk about the deployment of CASB. Thank you for your time. Goodbye.